Hello everyone and welcome to today's product update where we cover what's new in SimCenter AimSim 2404. For an agenda today, we'll be introducing Maya HTT, the organization that's bringing you today's update on SimCenter AimSim, and we'll dive right in to the new material, divided into two categories: what's new for the different libraries across the tool, and then what are some updates for the platform as a whole. So, a little bit about Maya. At Maya, we help organizations with their digital transformation journey. Siemens has recognized us as their top North American partner in 2021. We have over 250 employees and counting, and we count among some of the most awarded Siemens partners globally. We are happy to report over 95% in customer support satisfaction, and we are a business leader in North America and Europe. Our team comprises over 150 engineers and scientists mastering multiple simulation tools and domains, including some of the following you see here. We are a developer of more than 30 Siemens products, as well as being a provider of some of the simulation and test software worldwide. We are expert consultants and systems integrators across 7 disciplines that you see here, with more than 1,200 projects successfully completed. We are recognized for dealing with complex technical challenges and involved physics, and we are committed to industrial digital transformation across many sectors. And now an update on what's new in some of the SimCenter AimSim libraries. Aerospace and Marine. The first update is for the centrifugal compressor pre-design app, which is new to the 2404 version. It allows users to compute flow path and weight of centrifugal compressors and allows for the visualization of the centrifugal compressor layout. It will allow you to de-risk the design and integration of centrifugal compressors while accessing things like the weight penalty of a given design and being able to extract information to assess the engine transient behavior. The next update is the inclusion of a new marine generic sensor, which is able to be placed anywhere in the model and can sense data related to the water, the wind, and the ship performance for a marine ship model. The benefits here are that can greatly speed up the implementation of a control strategy model in your system simulations and allows you to get a better assessment of any part of the overall ship performance model in your analyses. Another new addition are the single and coaxial rotors found in the Flight Dynamics sub-library for aerospace and marine, which allows you to model simple and coaxial rotors as it states, which will account for things like flapping effects and cyclical pitch control dynamics. This allows you to design different rotorcraft and autopilot modes for those rotorcraft more quickly and more accurately model the dynamics. Allowing you to do things like assessing power requirements and accounting for the environment, as well as these rotorcraft can then be placed on Earth or Mars or otherwise. Next up is the fuel cell library with specific updates for particle exchange membrane type fuel cells. A new capability for the PEM fuel cell models in 2404 is the handling of the startup and shutdown sequences. So for dynamic simulation, a new capability has been added to handle those startup and shutdowns, where we can track hydrogen concentration at anode and look at the resulting cell voltage. The parameter identification tool has also been enhanced for 2404, allowing an improved operation for the app that allows you to preview results coming from the loaded CSV and being able to monitor in real time the convergence process that is the optimization of parameter identification within the app. We now also expose additional parameters that you can identify via the app for characterization of the fuel cell. A new app has also been created for the characterization of a compressor performance table Using data that will come from external sources, we can copy paste this into the tool and generate the performance map and resultant geometry of the compressor for the fuel cell. Moving on now to the hydraulic and hydraulic component design libraries. The first improvement is in the valve builder, where we have included the ability to pre-charge check valves. So in addition to the standard non-return valves that were able to be placed in the valve builder, we now have check valves that can include a pre-charge. We simply include the check valve in the architecture of the valve builder, and we can toggle on or off the check valve setting and be able to characterize some pre-charge in the parameters below. This allows you to be able to model pilot operated check valves or directional valves using the valve builder, just extending the capability of the tool. Another improvement is in the gear rotor pump CAD import capability, where we have the ability to toggle on or off viscous friction calculations and the associated geometrical considerations for that type of analysis. So this improves the accuracy of the gear rotor pump modeling using the CAD import capability and be able to give us a wider choice of parameters to be able to refine the model to our specific application. Next is the thermal library. A big new improvement in the thermal library is the inclusion of an enhanced fin heat exchange element that makes the modeling of the fins for heat exchange much easier than in previous versions. The element has been moved from the two-phase flow library to the thermal library to make it more accessible and modeling much easier, allowing you to reduce the number of components overall to model heat exchange across fins. In addition to reducing the number of overall components, the modeling has been simplified with more accessible parameters in one component and an app allowing you to simplify the process of geometry setting. Overall, this has accelerated the process of modeling fin for heat exchange in the thermal library. Finally, we see here a comparison of modeling the same type of heat exchanger with fin surfaces for heat exchange. On the left, the previous version using elements from two-phase flow, and on the right, the newer version that's using the more refined thermal library version of the heat exchange across the fins. Improvements in the two-phase flow library. Improvements have been made to the two-phase flow compressor mass flow rate correction in the two-phase flow centrifugal compressor component. Allows you to characterize the compressor more independently of the tested fluid. So this means that there are now corrected mass flow rate and corrected rotary speed parameters that allow you to update the characterization for a new fluid, for example, changing from air or hydrogen to one or the other, making the process more streamlined and more straightforward when working with test data from one fluid and characterizing for another. Another major improvement is to the mass flow rate correction that's now available for the slip ratio definition for the two-phase flow library. Previously, we were able to choose different correlations for the slip ratio between the fluid and gas phases of a liquid, allowing to model the different velocities. But now we are able to include user-defined correlations for further tuning and allowing better accuracy for that correlation and better matching of test data. And now for what's new with the SimCenter AIMSIM platform. So the new 2404 version brings solver changes and some optimizations to the solver, mainly better handling of large Jacobians and a refactoring for some of the two-phase flow material calls and other parameters that generally are improving the simulation performance and significantly so for larger models. On the right, we see the decrease in CPU time for models with an increasing number of states, and generally larger models are getting a better increase in performance all the way up to large numbers like 14,400 states. And now under Windows, an improvement to the available compilers in 2404, namely a streamlining of the Microsoft Visual C++ compilers, and an upgrade of the generic compiler provided by SimCenter AimSim, which is upgraded to version 13.1. Mainly, this means there's more compatibility with other tools across compilers, allowing you to take advantage of things like co-simulation with MATLAB Simulink. There have been some modifications to the analysis toolbar in SimCenter AimSim 2404, mainly that there is now a container to list all of the plots that have been attached to the model using a tile view. So this allows you to separate new plots and to reorder different plots within your simulation simply by using a drag and drop. So this easily allows you to access the different graphs and plots that you've saved to your model and identify more specialized ones that you might have and access more quickly. The ability to add more metadata to the CSV export has been included, where now we can attach things like model name, variable description, and result set number to the exported CSV data, allowing you to have more context working outside of AimSim with the results that have been exported from a simulation. In the CAD import domain, a new ability to import a model with 3D mechanical components now allows you to use the recursive method to do so, which allows us to avoid the error-prone manual process for getting frame positions and orientations of the different bodies, and be able to use the recursive method more widely across applications in the 3D mechanical library, which typically eases the process of modeling for this library. And here we see an example of that in action with, on the left, the 3D CAD model of the mechanism that we wish to import, and on the right, the mechanical model using the 3D mechanical library across AimSim, leveraging those recursive joints and the kinematic assembly that is created within the AimSim animation pane. And that takes us to the end of today's session covering what's new in the 2404 version of SimCenter AimSim. Thank you very much for your attention. My name is Anthony Larella, and if you wish to contact me for any further questions about SimCenter AimSim or other matters regarding system simulation, here is my information, and I can be reached at the following email address and phone number. Otherwise, for more information, feel free to visit mayahtt.com. Thank you very much, and have a great day.